So this is a parallelogram. Anybody have any idea what a parallelogram is? Raj.
Quadrilateral.
Oh, that's a good start. It's quadrilateral.
With two pairs of parallel lines on opposite sides.
Excellent. Love it. Does that work for you guys?
Yeah.
Isn't he smart?
Great job,
Yeah.
Raj.
Oh, wow. That is.
Wow.
It's almost like you've seen this before. So there it is. Opposite sides of parallel. Okay, so that's our definition. Yes, Dan?
So parallelogram has to be a quadrilateral. Like you couldn't have like
A parallelogram has to be a quadrilateral. Yes.
So you couldn't have like a hexagon that's parallel.
No.
Try to.
Parallelograms are like golden retrievers. They have to be a dog, but not all dogs, aka quadrilaterals, are parallelograms. No, I mean not all dogs are golden retrievers. Okay, good. And we'll do that business a lot when we start talking about all the different shapes. Like, is a square a rectangle? Is a rectangle a square? Is a square? You know, all that other fun stuff. This is the definition. Then we transition from here into all the properties of a parallelogram. Okay, so you've got to make a distinction between the two. So definition is easy to remember. It's called a parallelogram. Therefore, it's the opposite sides parallel. But what else is true about that thing? Dan?
It has four sides.
It has four sides, but we already took care of that in the definition by stating it's a quadrilateral. But still a true statement. What do you got?
It has two sets, or two pairs of.
Hear my stomach growl
She's just used to my stomach growling, so she doesn't notice.
So
Two.
you don't hear it anymore, is that it?
I didn't don't pay attention.
I understand.
Two pairs of congruent angles.
Two pairs of congruent angles. Which angles?
The opposite angles.
The opposite angles are congruent. Okay, does that seem right? Does this angle appear to be congruent to that angle? The rest of you? Yes. How about these two?
Yes.
Okay, let's go with it. What else? Come on, I'm not giving you this. No, we heard enough on you. Yes, sir.
Since the opposite angles are equal, then the opposite sides has to be equal because the angles are equal.
I want to pursue that in a second, but let me take care of the first part. So you're saying the opposite sides are congruent.
Yeah.
We okay with that? Top and the bottom look congruent? Left and the right look congruent? Love it. Okay, now explain to me why you know that they're congruent. What do they have to do with the angles?
Okay, so since the parallelograms are obviously parallel.
Hence
so,
the definition, yeah.
yeah.
Okay.
So the two opposite sides are congruent because of AIA. So that since the angles are congruent, and the side corresponding to the angle also must be congruent too. Also, I mean, it must be since the angle is congruent to the other angle, opposite angle, then the side corresponding to the angle is also congruent to the other angle corresponding to the opposite side because they're the same angle, so the sides have to be the same too.
I don't know. I know. Hold on. Caleb.
Could you split it into two triangles?
Oh, hold on. Don't. Okay, wait. Hold on. Let me resolve this first. We'll come back to your statement in a couple minutes, okay? And Bob, what do you got? That's you. Remember, you're Bob.
Yeah, but okay.
Go ahead. You can say it now.
You separate them into two triangles.
So you want to split it into two triangles? How?
Like from one of the angles to the other.
Which angle? You want to go upper left or upper right?
Upper right.
Upper right to the, oh, get rid of that guy. From the upper right to the lower left. So you want to split it into two triangles. Do you know what this segment's called, by the way? Okay, we'll get to it in a sec. Oh, no, we're not going to get to it now. We'll get to it right now, actually. That's a diagonal. How would you define a diagonal? Go ahead, Dan.
Line.
It's a segment.
A segment
Uh-huh.
that splits a parallelogram into two triangles.
that works in this case, but we also have a whole bunch of different scenarios for diagonals. So let's suppose I have a 1, 2, 3, 4, 5, 6, 7, 8. I've got an octagon, and I go from this point. These are all diagonals.
So then a segment that splits a polygon into triangles.
But if I just look at this one particular diagonal, it doesn't split it into triangles. Go ahead.
Does it bisect the angles?
Nope.
Goes from one vertex to the other.
One vertice to the other. A segment that goes from one vertex to the other. Okay, what about this though? What do you got?
Opposite vertex.
What does opposite mean? I got 6 other opposites there.
Each.
I'll help you out because it's tricky. A diagonal is a segment that connects non-adjacent vertices. Should I say that again? A segment that connects non-adjacent vertices. That takes care of this problem here. That's not a diagonal, that's a side. So you go to the non-adjacent. These are the 2 adjacent. So you go to non-adjacent and you get a diagonal. Okay. So, Caitlin, back to you. You wanted to split this parallelogram into 2 triangles. Why?
To prove that they're congruent, so you could say.
Okay. All right. So you want to prove that these 2 triangles are congruent.
Yeah.
How?
Couldn't you do hypotenuse side?
Nope.
Okay. Oh, side, side, side.
Side, side, side works great if we accept. Do we accept what Nick said about the opposite sides being congruent? Beautiful. So then if you do that, then we got reflexive property. And I'm still erasing. I meant to do that so I could draw that in. So then those 2 triangles are congruent, correct? All right, what if I draw the other diagonal in? What about those 2 triangles?
Oh, yeah, those two.
Those 2 are also congruent?
Yeah.
Can you summarize that into a statement that's true about parallelograms?
No matter how many triangles you draw, they're gonna be congruent.
Okay. How about if I do that? Are all those triangles congruent?
No.
By the way, how many triangles are in that picture now?
6,
6.
8.
There are 8. Are all 8 of those triangles congruent? No, but there are a bunch of pairs of congruent triangles. So we have the 2 pairs that we already talked about. What about these 2 guys? Yeah, why?
Oh, wait.
Well, I know that this is congruent to that. I know that that's congruent to that, but how do I get that that triangle is congruent to that triangle? AIA. Okay, I'll give you that. That would give me this and this. But, uh-oh.
No, angle side.
That's AAS.
Oh, you're right. Sorry, it's not this. It's angle, side. Good, so these triangles are congruent.
Yeah.
How about this? Can we do it over here too? Yeah, I got that congruent to this. Okay. So, after everything is said and done, Kaylin's introduced an idea that says if you draw in a diagonal or both diagonals, we get a bunch of pairs of congruent triangles. Are we okay with that? Good. Now, what can you tell me about the diagonals now that we have, let's get rid of all this mess and start over. If I just do this, what can you tell me about the relationship between the diagonals? I'll give you a hint. These 2 triangles are congruent and these 2 triangles are congruent. Nick, are you raising your hand?
Yeah.
What do you got?
They bisect each other.
Beautiful. This is congruent to this. This is congruent to this. Not all 4 things are congruent. 2 pairs of congruent chunks. Okay, so let's summarize. We know the opposite sides are parallel because of the definition. So you've told me that the opposite sides are congruent. The opposite angles are congruent. The diagonals make a bunch of congruent triangles. The diagonals bisect each other. think we may have everything. Let's see. I got that. We got that. Opposite sides are congruent. We got opposite angles are congruent. There's a picture of that going on. Isn't that pretty? Great. Let's move on. We've got, oh, we missed this one. I gave it to you. Darn it. Consecutive angles are supplementary. And then you got this one. So consecutive angles being supplementary means that this angle is going to be supplementary to that angle. Why? What kind of angles are these? Mm-hmm.
Interior.
What kind of interior? Guys in black suits operate internationally.
CIA.
Correct, they're CIA, consecutive interior angles. And since this is equal to this, and this is equal to the opposite one, we have the fact that any angles next to each other will be supplementary. These two add up to 180, these two add up to 180, those two add up to 180, and those two add up to 180. We did good, almost got all of it. Okay. So again, the first thing is a definition, the opposite sides are parallel. Everything else falls under the property of a parallelogram. Whoops. There we go. Okay, find angle D. As in donkey. Don't be bashful about getting out those calculators. Okay, who are we missing again today? Olivia, who sits in front of you?
Amber.
Is that it?
Well,
Who's this?
Greg.
Greg's been gone a while. Okay, so that's 2, 1, 5, 6, 7. 7 is 23. Okay, making any progress? Yeah, good. Johnny, what's X?
What is that?
Y.
You said angles A and C equal to each other, so they're congruent.
Good.
And-
Because the opposite angles in a parallelogram are congruent by the property of a parallelogram. I'm with you. Good. So you set them equal?
Yeah.
Okay. Then how big's angle D?
Well, first, I substituted X into either one, so
Which one did you do?
A.
And found out that A is how big?
I'm actually improvising, I didn't get this far.
I understand.
99.
See what you're doing.
99.
99. Do we agree so far? Which makes angle C how big?
99.
Not that we really care about that, but if you would have plugged it in over there. So what's the answer to the question then? How big is angle D?
81.
81. Why?
Because angles A and D, as well as D and C, are supplementary.
Beautiful. Well
So
done.
to subtract 99 from 20.
Okay, good. Any questions on that one? Okay, good. Moving on. Okay, oh, look, 81. Yay. Okay, so now we got coordinate plane. 4 points on a coordinate plane. You could graph this if you wanted to, just for reference, but it won't do any good. You can't really count on a coordinate plane. Or what I would recommend, even if you don't graph it, I would recommend drawing a sketch. So on the next slide, I do have a coordinate plane that we can graph it onto. The reason I suggest drawing a sketch is, well, I'm going to ignore this for a second. Let's go back to the other one. I want to draw a sketch because I need to keep track of sides here. So we talked about labeling yesterday, R, S, T, V. Doesn't have to be labeled like that, but it does have to be labeled in the correct order around the parallelogram. The reason I draw the sketch is we're going to start doing some calculations. I want to be sure to work with the sides and not the diagonals. Not getting diagonals confused with sides. Okay? At this point in time, we only have one way to prove that that's a parallelogram, and that is to show that the opposite sides are parallel. How do I show the opposite sides are parallel? Somebody else. Just up. How do you show the opposite sides are parallel?
Do you find the slope?
Are you asking me or telling me?
You find the slope.
You find the slopes. Excellent. So do that. Find the slopes. Erica, you have RS. Faith, you have VT. Camilla, you have RV. And Natalie, you have ST.
Okay.
And we'll use the rest of these jamokes as backup. Make sure you did it right. Christelle, coming back to you, if it is a parallelogram, what are we going to find out about the slopes?
That you would have two of the same slope.
Just shout it out when you got your answers.
5 halves.
RS you had, right?
Yeah.
Is she right? Good. I got one. That's enough for me.
5 halves.
I assume you had VT?
Yes.
2/5. IST. Well, RV is 2 or 5 too. So.
2 or 5?
Yeah.
Thank you. We tried to steal your glory there. 5 halves and 5 halves, parallel. 2/5 and 2/5, parallel. Not perpendicular, because we know that perpendicular has to be an opposite reciprocal, not just a reciprocal. But again, if you wanted to slap that on a graph patch or on a piece of graph paper just so you have it as a reference, you could, but it's not necessary. I would, however, strongly recommend that you draw a quick sketch. Because notice, if you don't realize which one the diagonals are and start doing some calculations with the diagonals, it's going to give you all kinds of wonky numbers. Okay, RT and VS are not sides, they're diagonals. Whoops, keep doing that. Come on. There we go, okay. We talked about this already. The diagonals bisect each other and they divide it into a whole bunch of congruent triangles. That's done. Nice. Okay. Using that information, solve for RS and T, please.
Are you saying that angle ZYW is 18 degrees?
ZYW, yes. And angle WYX is 40. And the segment from X to that center point is 7S plus 3, and the distance from Z to that center point is 8S. And the capital of Peru is Lima.
Yes.
And cows can walk upstairs, but not downstairs. Mm-hmm. I learned that the hard way in college.
I tried to have a cow walk downstairs.
Kind of. I don't want to go into details.
Alright.
Court settlement, I can't talk about it.
Okay.
I do know that they can walk upstairs though. But not so
Same
much.
experience.
Let's just say somehow a cow ended up in a rival fraternity's upstairs facilities. How it got there, I'm not sure. But I know when it came time to bring the cow downstairs, it didn't go so well. It's just a story I heard when I was at U of I. I can't, I mean, I don't know who would do that to a cow, but I'm recording this, aren't I? Got that part out. Any luck on RS and T? Dan, what do you got?
S equals 3
Why?
because WY bisects CX, so then 8S is equal to 7S plus 3. So if you set those equal to each other, you get S equals 3.
Beautiful. Jocelyn, what do you got?
I got that, R equals 4.5.
Why?
Because, WX is parallel to ZY,
Mm-hmm.
so they equal each other.
Just because they're parallel, are they equal?
Or, the side ones are equal.
There you go. They're congruent. Okay. And anybody with T? We got. Well, we heard from Brandon. You got T?
T equals 20
Why?
because it's alternate interior of 40.
Beautiful. Good. These are alternate interior angles, and therefore you can set those equal and solve. You could have found T. Did anybody find T a different way? There's a much more complicated way to find T, but we'll just leave it at that if everybody did that. Okay, good? Problems? All right, so again, using all the, not all of them, but most of the properties we talked about. The opposite sides are congruent. The diagonals bisect each other. These sides are parallel, therefore we generate alternate interior angles. Good. All right, solve for x and y then.
The y on the bottom right is just the point.
That's just a label, yeah. That's not a variable. Becca, any progress?
No?
No? Claire, progress? No? What else have I heard from? Right, any progress?
Yeah.
What do you got?
Y equals 13.
Anybody else, 13?
Yeah.
Okay, good, tell us how you got that, please.
I added 45 and 70 to get 115,
Uh-huh.
and then I subtracted that from 180
Why?
because to find angle D is there CIA, right?
No. Oh, yeah, they are, I'm sorry, you're talking about this whole angle.
Yeah.
Yeah, these two are CIA, all right, good.
And then I divided what 180 minus 115 is 65, and I divided that by 5 to get 13.
Great. Did you get x too?
Yeah,
What's x?
70.
70, yes?
Oh,
No, 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 10, 10. 10?
Yeah.
Yes.
Yeah, yeah, how'd you get that?
I did 7x minus 5 equals 65.
Good, because once you found angle D in the other part of the problem, you knew that that was 65, the opposite angles are 65, so set that equals 65 and solve. Beautiful. Okay. Questions on that? You could have also looked at the triangle. How big is this angle?
45.
How big is that angle?
70.
So you could do triangle sum if you wanted. What you can't do is set these two equal to each other. Two variables, one equation. Not solvable. Okay, quick summary chart then. Opposite sides are congruent. Opposite angles are congruent. Consecutive angles are supplementary. diagonals bisect each other, but again, remember those 4 parts are not congruent. 2 pairs of congruent parts. And then we looked at all the possible diagonal things that we could draw in and all the weird triangles. These are all properties of parallelograms. The fact that the opposite sides are parallel is a definition. You will have to make a distinction between the two. Okay, we good? So again, seems fairly simple, yes?
Yeah.
Okay, again, it will get more complicated as we introduce more and more. Tuesday, 10 o'clock, first Tuesday of the month. Okay, I got new seats for you.